Welcome to this video. Hello, welcome to this video. So in this video, I want to do two things. Okay, firstly, I wanted to show you some unit conversion, a demonstration of unit conversion. And the second thing is I wanted to show you maybe a more concrete way of calculating dimensionless numbers. Okay, in such a way that you actually do unit checks. Okay, so let's do the unit conversion demo first. All right, so over here I have a function called unit conversion demo, which says 1000 meters equals to 1 kilometer. All right, so how does this actually work? Okay, so I have this unit conversion demo function being run in my main. Okay, and my unit conversion demo is here. Okay, so let me delete the code and I will explain as I run. So whenever we instantiate a new quantity like a length, we can instantiate a new quantity like a length. We can specify the units over here. So for example, I can put here kilometer, and I can put 1 kilometer, 1.0. Right? So print line. Then I can put the curly braces with a question mark, and I can put D over here. And that will print how many kilometers that is. Okay, so as you can see, if you just define a new quantity called kilometer, it will automatically be formatted to meters. So if I were to say I want to put foot, for example, I want to put foot, it will do the same thing, FOT, foot. And if I just do this, FOT, foot. Okay, 1 foot is about 3048 meters. Okay, it will do this auto conversion for you by default to SI units if you do it. If you specify everything in SI units, as you can see here, UOMSI, everything is by default converted to SI units. How about if you want to convert this kilometer? Okay, how about if I want to actually display how many kilometers that is? So let's show you how to do that. Let D in converted equals to, well, what do? There is this method called the get method. So it retrieves the value of the quantity in the given measured unit. So the way to do it here is, okay, I have the object called D. Okay, D is the object. D is the object of the quantity. It is an object or structure. Okay, so I will use the get method. And what's the get method need? It needs an input parameter. The input parameter here is the unit. So I wanted to convert it to meters, or I want to convert it into a kilometer unit. Okay, and then I'll save. Okay, so and then what I'll do is I will try to print this out using the question mark and the curly braces. And I'll put D converted right here. Okay. So you can see that over here, I have this 1000 meters equals to 1 kilometer. And what is the return type? Okay, return type is it just gives you the value. Okay, it just gives you a value. So it retrieves the value of the quantity in a given unit. Okay, it just retrieves the value in a given unit. So this thing here isn't actually what do you call that? It is not actually it's not actually a quantity. It is just a float. Okay, if I do this float 64. And I just return D converted. Yeah, it will run like correctly, except over here it's F32. So this thing it says it expected F64. It found F32, which is float 32. So I can just use the into method. So this thing actually returns a float. It doesn't return it does not return any kind of actual quantity. For that, you have to instantiate everything from the beginning. Okay, so this is how the unit conversion can actually be done using the get method, and then you'll just get a double or a float depending on whatever you use. But in this case, it is just a 32 floating point. Okay, if I want to change it to double, I can just change this F32 here to F64. It will do the same. It will do pretty much the same thing. Okay, except with a higher precision. Yes, so that's unit conversion demo. Important. Second thing is, well, for my previous video of calculating the Reynolds number, what I did first is to calculate the Reynolds number and then just obtain the value. Okay, I just obtain the value. So this is getting a float value without actually performing any kind of unit checks. So that's a little bit alright. You may or may not be comfortable with it, but in a sense, if you really want to be unit safe, you're gonna make sure the Reynolds number here, this quantity should actually be dimensionless. How do you do that? Okay, so first thing first, what I found out was there is actually a ratio unit. Okay, so under UOM source SI, you keep scrolling down. There is this thing called a ratio. If you can see this ratio here, this ratio here actually is a dimensionless unit. You can see that the dimensions here are all Z0, Z0, Z0. So Z actually stands for 0, and the number 0 actually stands for 0 also. Okay, in this naming convention. So this is actually a dimensionless unit. Okay, so to give you another example of a dimension unit, for example, you can go and look at area. Okay, area, you can see that length is P2. P means positive, 2 is to the power of 2. So this has a dimension of length to the power of 2, or power of positive 2. If you want a negative number, you will see the letter N there. And then you will see, for example, molar volume. Okay, molar volume. You see, molar volume is here, meter cube per mole, right? Meter cube is positive 3, so length is positive 3. Amount of substance, which is mole, is negative 1, which you can see over here. So Z actually stands for 0, N stands for negative, P stands for positive. So do keep that in mind. So given this information, you will actually see that the dimensions here are all Z0. They're all 0. This is a dimensionless quantity. So what I can do here is that, okay, this thing should be a dimensionless quantity also. How do I then check whether it's a dimensionless quantity? Alright, so the way I do my checking, one possible way of checking, it may not be the most efficient, but this is one way that can work. It is called convert dimension. I can make a method called convert dimensionless number into double. Alright, and what I'll do is, okay, I specify the type. Okay, I'll put a dimensionless number. I put a dimensionless number. It's a bit of a verbal, so a very long name. Dimensionless number. Let me put this second line. Dimensionless number. So what's the dimensionless number? I will call this is a type of ratio. Okay, it's a type ratio. So you can see that over here, rho is the type mass density. Okay, so this thing has to take in a ratio kind of quantity type. And what is the return type? F64. And then what I can do is this. I can actually return, okay, return the dimensionless number dot value dot into. So this will actually convert everything nicely into float 64. How is this actually checking for you? So basically, this function only accepts dimensionless numbers if they are in the form of ratio, meaning to say if they are in this quantity form. Okay, this ratio is a quantity, but it is a dimensionless quantity, as you can see here. And of course, Reynolds number is a kind of ratio. So it is in the correct unit set. So if you have a quantity in the correct unit set called ratio, you will be able to just, this function will actually just take it in. Otherwise, this function will return an error and you will not be able to compile the code. So what I'm going to do is, I'm going to put Reynolds number here. I will use the convert dimensionless into double, and I'll put a Reynolds number over here. And this will actually check for us that this is actually working. Now, how do I know that this is working? Well, let's try doing the convert dimensionless number double into double. We use this function on something that is actually has a dimensions. For example, d, which is the length. So I can try using this function here. On the d or d converted. So I run convert dimensionless number into double. Let's try d converted. Okay. So d converted is not the correct type because it's a floating point 32. So you cannot put it in. So that is, if you check, I mean, it's definitely a dimensionless number, but it's not a quantity. So this will fail the check. So that's one way of protecting yourself. And if I go and put d over here, okay, what will it say? It says the arguments to this function are incorrect. Okay, arguments to this function are incorrect. It says it expected struct z0 found struct p positive integer. So what it's saying here is that, yeah, this thing is not dimensionless. I mean, the error messages aren't great here, but you know, it works. So let's see. So if I were actually to put something like d over d, this in theory should work. See? If I put d over d, then d over d is actually the correct quantity type. So therefore, this convert dimensionless number into double will work, just as long as this dimensionless number is actually of the type ratio. So this is one easy way to actually check that your dimensionless numbers are truly dimensionless. Okay, using a function like this, and you should be fine. Okay, so that's it for this video.